Hello and welcome to Apply Database 1. After creating the database design or schema, we can start creating the database itself using SQL statements, which can be divided into three categories. The data definition language statements, which are used for creating tables, relationships, and other structures. Data manipulation language, and those statements are used for queries and data modification, and the SQL persistent stored modules statements which add procedural programming capabilities. This session will address the statements that will be used to create the tables, their columns, relationships, and related constraints. The structured query language, the SQL, was developed by IBM in 1970. In the 1970s, the early 70s, endorsed and used as standard language in 1992. Since then, newer versions have been created to incorporate XML and some object-oriented concepts. SQL is not a full-featured programming language like C, C Sharp, and Java. SQL is a data sub-language for creating and processing database data and metadata. SQL is universal in enterprise class as a database management system product. SQL programming is a critical skill. Some of the statements that will be used to manipulate the database is listed in this table. For example, we use the statement select to retrieve data from one or more tables, while we use the statement insert to add new rows to table. The statement update changes existing rows to in the table, and the statement delete or drop deletes existing rows from a table. So we can delete rows and drop columns if we need. Some of the statements that will be used in the data definition language are listed in this slide and the next few slides. For example, to create a table, we use the statement create table. We can also create a database user, create a sequence of automatically generated numbers, and create an index for the table. The statements in this slide will assist in altering existing information in the database. The alter statement will allow you to make the required changes in the database. You can alter user, alter table, alter sequence, or alter index. As we created users, tables, sequences, and indexes, we can use the drop statement to delete what was created if needed. We can use the grant statement to grant privileges to a user, and we can use the revoke statement to revoke privileges from user. To understand how to use these statements, we are going to go through the Viewridge Gallery example. Viewridge Gallery is a small art gallery company that has been in business for 30 years. It sells contemporary European and North American fine art. Viewridge has one owner, three salespeople, and two workers. Viewridge owns all of the art that it sells. It holds no items on a consignment basis. The Viewridge would like to have a database that will track customers and their artists' interests. And again, listen to the requirements for the company. So they are telling you exactly what they need. They need to track customers and their the artist and their artist work. They need to record the gallery purchases. They need to record customers' art purchases. List the artist and works that have appeared in the gallery. Report how fast an artist works have sold and what margin show current inventory in a web page. The database design team created for us the following database design. So let's assume that we have a team that worked on the design and created for us the design that we see here in this figure. As indicated by the small business owner and the design team, we have four main tables. So the owner told us that we need to track this, and we created based on that the four main tables that we have: customer, transaction, work, and artist. And of course, we have one intersection table. Remember why we used intersection table. If the relation is many to many, we use intersection table, and that's why we replace the many to many relation, or we use the intersection to connect those tables together. This design shows the relationships between these tables. You can see the one to many, many to many, and you can see the optional to mandatory relationships. Let's start with the first two tables, artist table and work table. In the artist table, we have the following columns: the artist ID, name, nationality, birth date, and deceased date. Since we are working with Oracle, we are going to change the data type to fit with Oracle Database Management System. For artist ID, instead of database integer, we will change it to number. Birth date and deceased date can be changed to date, or we can leave it as number if we are looking for just the year. If we are looking for the day, the month, and the year, then we'll change it to date. If we are looking for just the year, we'll keep it as number. The same will be applied to the work table, where we can look also at the different columns, the data types, and the size. And then the null and not null constraints also will be included or can be added to the code. So to create the artist table, we use the following code. As you can see, it's straightforward. Create table artist, and then we open brackets or parentheses, and we start adding the columns. Artist ID. Artist ID, the type is number. So we have the column name, we have the data type, and we have the null, not null, and that will give me the information if it's optional or mandatory to fill. So this is the optional constraints: null or not null. Can we leave it, leave this field without filling, or we have to fill that field? And when we say not null, then it has to be filled. If I don't have anything after that, then the default is null. The default to leave it blank. So this is how we write the code for the table. Columns, their data types, the size, and then the null, not null constraints. At the end, we specify that I want the artist ID to be my primary key. As you can see from the code, we have the column, we have the artist ID number with 1 and 0. 1 in this case is called precision, which is the total number of digits in number to the right or to the left of the decimal. So if we say that the precision is 15, so the total number of digits will be 15, whether it's on the right of the decimal or to the left of the decimal. In this case, the 0 is called scale, and the scale means the number of digits after the decimal on the right hand side. So in this case, no digits to the right of the decimal. To implement that, we are going to use Oracle Live SQL. Oracle Live SQL. Since many students had a problem downloading and installing Oracle before, we are going to use the cloud, which is called Live SQL, to Oracle Live SQL to implement our code and to see how would that work with us. So you can see the implementation that you did. Um, so this, since it's on the website, it works for students with Windows, Apple operating system, Linux, or any operating system. So you don't have an excuse for not doing this, not working on this. It can work from your laptop, your desktop, or any portable device. You can click on Start Coding, and once you click on Start Coding, now you can create an account with Oracle, then start the coding. Creating the account will not take time, just a few questions you fill, and they will give you access for the Oracle Live SQL. Write the code that we did, which is create table in Oracle Live SQL, then click the run. Once you click on run, you can see that a statement came back and said table being created or table created. So you add the code under the SQL worksheet. You click on worksheet, add the code, click on run, and you will get the result back saying that table being created. This slide is a reminder of the allowed data types in Oracle. And we talked about that in a previous session. During the creation of a table, we can add the required constraints. We can also add constraints after creating the table using the alter table statement. There are 5 types of constraints. We have the primary key, which may not have null values. We have the unique, which may have null values. And we have the null, not null constraints, and we have the foreign key, and we have the check constraints. And again, I'm going to give you an example on each one. So we create the second table, work. In this table, we have 4 columns. Then we add the artist ID column as a foreign key to connect the 2 tables. Notice that artist is the parent table and work is the child table. So the relation is one to many. One artist can have many artworks. So to connect the 2 tables, we add the primary key of the parent table as a foreign key in the child table. And this was one of the rules that we learned in the last session. Then we add the constraints to ensure referential integrity constraints. So we are referencing this foreign key to the table that came with it, and that will make sure that any changes that will go here, it will be reflected in the second table. The work ID will be number with a precision of 35 and scale of 1, which means that the total number of digits is 35. So 34 of them will be on the left and 1 will be on the right of the decimal. Again, take the code and implement that code in Oracle Live SQL. So you can write this code to connect the 2 tables. So you have now the artist table and the work table being added. How about minimum cardinality? So we use the null not null constraints to define if it's optional or required as follows. If we are saying one to many relationship, then we can make, if the parent is optional, we specify foreign key constraint set a foreign key as null. In the foreign key it will be null, and by doing this then we are allowing the parent to be optional. If I want the parent to be required, then the foreign key will be not null. The foreign key will be not null. If we have a relation of 1 to 1, then the with parent is optional, then we specify that foreign key constraint can be unique constraint and set to null. If one-to-one relationship parent required, then we specify foreign key constraint, then we specify the foreign key to be unique, and then we set the foreign key to be not null. If we have a causal relationship, we create a foreign key column but do not specify foreign key constraints. If relationship is one-to-one, we can specify that the foreign key is unique. The default values and constraints can be identified as follows, and those constraints is based on the business owner, the company. The company is providing you with these limitations, constraints that you need to follow. So in this case, they are saying for you that the artist nationality will be only from these countries, no other countries. So we have 1, 2, 3, 4, 5, 6, 7, 8 countries. So we need to check if whatever being added is within these countries, and that's why we have constraint that's called check in, and between parentheses or brackets we can put all the countries that are allowed. And then we have the birth date. It's supposed to be before deceased date but not after, so we have to make sure that it's before, not after. Sometimes you enter or somebody enter a date that is wrong, so the database by itself will verify that this date is wrong and it will give you an error message until you correct that. We can also specify that the birth date will be 4 digits, which is the year only. That's why we have it as number. And then we can specify that the first number or the first digit will be only either 1 or 2, and then the other digits will be allowed to vary from 0 to 9. And the same applies for the deceased date. For the sales price, it will be greater than 1,000 and less or equal to 200,000. And for the purchase date, it will equal or greater than the date that it was acquired. Since the table has been created, we can add all suggested constraints through the alter statement that we talked about. So the alter statement changes table structure, properties, or constraints after it has been created. For example, we can say alter table artist add constraint, and this is the constraint that we need to add to check if the nationality values is equal to these countries, the 8 countries that we specified. So we can say constraints, it's called, that constraint itself is called nationality value. So this is the name of my constraint, and we are going to check. So it's a check constraint. The type of it is a check constraint. What are we checking? We are checking nationality where in those countries that I'm allowed to have. If I have any other country, it will give me an error message and say this country is not included or not allowed. We can also alter table artist and add constraint to the birth values, and we can say that we need birth value check, that's another check constraint, to be less than the deceased date. So I need to check if the birth date is less or not. If it's not less, then there's something wrong, I need to fix it. We can also enforce certain format for the birth date using the like statement. So we are going to limit, as we stated before within the constraints, that the first digit will be either 1 or 2, while the other digits can vary from 0 to 1. And the same can be enforced on the deceased date. So this is another check constraint that I can add to the table. You can also delete the constraint using the drop statement, um, then add the correct format if needed. So if you thought that you added the wrong constraint, it's fine. You just drop that constraint and add a new one. So click on the schema when you go to Oracle Live SQL and click on the schema, um, and select the artist table to view. You will get all the information about the artist table. You can see the table attributes, the columns. You can see the data type, size. See, we have number, character, date, or number if we need to change that into number, and the length, the precision, the scale, so on. And in the second one, you can see the constraints too. So we have also constraints included. This is the code for creating the artist table with all constraints included. You already have that done. If that's what we did actually when we added or implemented the code for the table itself, and then we started altering the table. Um, the other option, instead of altering, if we have everything ready and we can enter it all at once, we can just take all this code and implement it, and we will have the table with columns, with the different data size, data type. We will have also other constraints that will be included within the code. What if we need to add another column for the artist table, such as email? We can go back to schema, and you can see the table being added through this code. So we just alter table artist and add email, and its variable character too, with size of 100, and it can be null. And once you implement it in the Oracle Live SQL, it will say table altered, and then you check in the schema, and you can see that the email has been added. You can alter your table and drop the column you just added if you want. So if um, you thought that you added that by mistake, it's fine. Just alter table artist and drop column, which is called email in this case. And you can go back to the schema to confirm that the column has been deleted. You can also use the drop statement to delete a table. Since you already created some constraints to connect tables, you might not be able to drop that table until you remove these constraints. Once we are done creating the tables, we can start inserting the values into the created columns. The figure shows that values have been inserted into the table, and it says that one row inserted. So you can just insert into artist, and what are the columns? We have the artist ID, the name, nationality, birth date, and deceased date. The values will be 9. That's for the artist ID. Name is Tamayo. The nationality Mexican. The birth date is 1927, and the deceased date is 1998. So we did enter some information in the database using the insert into command or statements. You can also use the update statement to update the data within the table. In this case, we are changing the nationality of the artist number 9 to Canadian. So you can see update artist, and artist here is the table name. Set nationality equal to Canadian, where artist ID is equal to 9. To delete a record, you can use the delete statement, but you have to be careful because you need to specify which record you would like to delete using the where statement. If you don't have this where statement, it will delete all records. So you have to be careful when you use delete from artist. If you stop after delete from artist, it will delete all records. Be careful when you do that. That will be all for this session. If you have any questions, please let me know. Thank you and have a great day.